or at different times of the day, it's going to have a slightly different appearance. Let's say you went out around noon every day and took your photographs. Well, if you started at the equator and you worked your way north, what would happen is the analemma would be horizontal when you started out, and it would become more and more vertical as you made your way towards the North Pole. But the time of day also matters. So at any given latitude, the analemma is going to change, and it's going to rotate a little bit as the day goes along. So if you take photos for your analemma early in the day, it's going to have a different tilt than it will be later in the day. So not only does the latitude affect what the analemma is going to look like, but the time of day that you take the photographs every day. And it's got to be the same time every day or every few days when you take it, and the same location, of course. What's different about the southern hemisphere? It just inverts it. It flips it upside down. Well, if I want to get into it more technically, we've talked about how you create an analemma, but what does it represent? Well, it's a plot of something called the equation of time versus declination. And that's a fancy way of saying that the north-south components represent something called the equation of time, which we'll get into it in just a second, and the east-west components represent declination, sort of our tilt with respect to the sun. Well, in order to get down to this equation of time thing, there's some things that we have to understand about the Earth's motion around the sun. There's basically three motions of the Earth that are relevant to the conversation that we're having right now. The first is the spin of the Earth around its own axis. Now, if you view that from the North Pole, that spin is counterclockwise. And it also advances around the sun in a counterclockwise way if you look at the solar system from the north. So the spin and the rotation are in the same direction. But here's the rub. If you're trying to figure out what the length of a day is, we typically measure the length of a day by just talking about noon to noon. So noon to noon is typically the length of a day. But because the sun is rotating in the same direction as it's advancing around the sun, the length of a day measured with respect to the point sun at its highest point in the sky is a little bit different than the length of a day if you measured it with respect to a star in the night sky, for instance. So if I were to look at any bright star in the night sky and say, the length of the day is now defined by